Why do we need proper relationship? Because we need high read throughput. A lot of people say that ACID compliance or consistency compliance is what the primary difference between SQL and NoSQL, but that's not true. You must have seen that MongoDB is primarily designed for ACID compliance. Hi, I am Lakshay and मेरे को 3 साल का एक्सपीरियंस है एज अ प्लेटफॉर्म इंजीनियर. लेट्स स्टार्ट विद द टुडेज टॉपिक विच इज़ हाउ टू चूज़ बिटवीन SQL एंड NoSQL डेटाबेसेस. ठीक है. First of all, to choose between a NoSQL and SQL database, we need to define a set of parameters. Let's choose our first parameter. What will be this? It will be relation. So why relation? Because the primary difference between SQL and NoSQL is relation. Let's understand this with an example. Okay, we have e-commerce order process and we have payment ledger. Okay, to understand relation we need to define a set of objects. Okay, so in case of e-commerce order process we have users, we have orders, we have items, we have payment logs. So we could say that items is related to orders. In each order there could be multiple items, right? And orders are related to users. For each user there could be multiple orders, right? And payments, it is related to orders because for each order there could be multiple payment logs. How exactly? Because there could be first payment that has failed and the second payment that was a success. Okay, so let's try to define a relation in payment ledger. Okay, in payment ledger we have three things: payment from, payment amount, and payment to. Okay, payment from and payment to are just IDs. Okay, ID, and payment amount is an positive negative integer. Okay, let's say plus 200. Okay, so if you look correctly there is not much relation. This whole thing can act as a document itself, and we could duplicate the payment from and payment to, okay, in each document. Okay, but in this case each and every object is somehow related to each other, so we need to define a proper relationship between them. And why do we need proper relationship? Because we need high read throughput, and that's the key. Okay, SQL is primarily designed for high read throughput in complex queries, and by complex queries I mean complex relations. Okay, while NoSQL is designed for high write throughput and also high read throughput, but high read throughput is only when the relationship is not complex. So how NoSQL stores data is in append only format, while SQL makes relations, so that our high read throughput in case of complex relationship. Okay, so the first point is relation, which is the primary difference. A lot of people say that ACID compliance or consistency compliance is what the primary difference between SQL and NoSQL, but that's not true. You must have seen that MongoDB is primarily designed for ACID compliance and also consistency in distributed clusters. Isn't that crazy? So the second parameter will be throughput. Okay, read throughput and write throughput. So in case of write throughput, MongoDB always wins. That's because, not MongoDB, I should say NoSQL always wins. That because it is in append only format. While in read throughput there are two cases: either the relationship is complex. So if you see that read throughput is also dependent on relationship. If relationship is complex, in that case SQL will have higher read throughput, which means that it could read a lot more data in a second than a NoSQL database. But if a relationship is not very complex, in that case, MongoDB or NoSQL will have higher read throughput. Okay. So now our third parameter is ACID compliance and consistency partition tolerance. Okay. So if you look correctly in payment ledger, we need higher consistency, right? But as you have seen that this type of use case is primarily designed for NoSQL. So in NoSQL also we need to choose a particular database, and MongoDB is that one because MongoDB is primarily designed for ACID compliance. Let's also understand the ACID compliance and CAP theorem. Okay, so when we talk about ACID, what do we actually means? A in ACID stands for atomicity, while C in ACID stands for consistency, I stands for isolation, and D stands for durability. What is atomicity? Atomicity refers that a transaction will either happen or it will not happen. So for example, let's again take the example of use case 1, which is e-commerce order process. In that case, if user takes an order, okay, so we need to update the database to reserve items, right? So let's say orders is successfully logged but the item reservation fails. In that case, we need to roll back the orders part, right? So atomicity ensures that if items fail, then orders log will also be rolled back. Okay. And that's what we call a transaction is should either be complete or should be rolled back. Okay. And that's what is atomicity. Now let's try to understand consistency with example. Okay. So first of all, what is consistency? Consistency basically means that the data should always be consistent. Okay. So we could take an example like inventory could never go below 0. And we could also say that payment balance could never be negative, right? Okay. Now let's try to understand isolation. By the way, isolation is a topic by itself and there are 5 layers of isolation. We'll not go in depth. So isolation basically means that if two transactions are happening at the same time, okay, the one transaction will not see the update of the other transaction until that transaction has committed its update. Okay, how MongoDB does it? It serves the snapshot of the data. Let's say two transactions are one is trying to read the payment balance while one is trying to update the payment balance. Okay, so until the write update commits, the read will not see the updates. That's what isolation is. Okay, now let's talk about durability. Durability basically means that if the database dies, let's say out of connectivity issues or out of power issues, out of nowhere it dies, it is going to replay once it restarted. The changes that has been committed will never be lost. Okay, that's how simple durability is. Now let's try to understand CAP theorem. In CAP, C stands for consistency, and the point to be noted is that consistency in the ACID compliance it is not same as the consistency in CAP theorem. That's because when we were talking about ACID compliance, we were talking about single node of database, while in CAP we are talking about distributed clusters where are multiple replicas. Let's say a single replica read and write replica. Okay. So here consistency actually means that let's say one transaction is trying to read the payment balance while the other is trying to write the payment balance, okay, in the write replica. Let's name them and read. Okay, so consistency here means that if the write is committed, it should be read instantly by the other transaction that is trying to read from a different server. A in CAP theorem stands for availability. So some databases like NoSQL database trade off consistency with availability. Okay. They prefer that read endpoints should always be available. Yeah. And P stands for partition tolerance. Okay, so if partition tolerance happens, which is basically a network distribution, so let's say they both are connected with the help of network, and this network breaks. So the databases that are primarily designed for availability and partition tolerance will still keep the read running, while if they're designed for consistency, then the read database will be stopped and the consistency will be maintained. Okay, that's what cap theorem is. Okay, so these are the three parameters we define the difference between SQL and NoSQL. And even in SQL and NoSQL, we define that which database should be chosen. Just like MongoDB is primarily designed for consistency and partition tolerance, while Cassandra is designed for availability and partition tolerance.